Hello students, today we're going to be talking about prime factorization. Now let's go ahead and start off at the top of our notes page where we're defining the difference between a prime number and a composite number. For a prime number, it has factors of only 1 and itself. Now remember, when we use the word factors, we're talking about two numbers that when multiplied together make a product or make an answer. Okay, so that's a factor. It's a number that's being multiplied with another number to make a product. So for example, 3 is our product, that's our number, and its factors would be 1 times 3 or 3 times 1. Those are the only two ways that you can compose 3 or make a product of 3 for 3 to be your answer. So therefore 3 has to be a prime number because it only has factors of 1 and 3, 1 in itself. As for composite numbers, a composite number is a whole number that has factors other than 1 in itself. So in this blank space here, I want you to write factors. So this means that multiple different numbers can be multiplied together in order to make a product, in order to give you a composite number. So for example, we have 8. The factors of 8 include 1, 2, 4, and 8. When multiplying those numbers together, you can get 8. You've got 1 times 8, 2 times 4, 8 times 1, or 4 times 2. This makes it a composite number because there are multiple different ways to get a product of 8. Farther down on your notes page, it says, create a key below, color coding the prime and composite numbers. 1 is neither prime nor composite, so it has been grayed out for you. Okay, so what I want you to do with your pencil is I want us to go ahead and shade in all of our prime numbers. So, the prime numbers that I have here are 2. So you can go ahead and circle 2. 3. 4 is not a prime number. It's a composite number because you can multiply it with 1 and 2 in order to get 4. So we're going to skip that one. 5 is a composite or a prime number, excuse me. 6 is a composite number. Some of its factors are 1, 2, 3, and 6. 7 is a prime number. You can only multiply 1 and 7 to get 7. 8 is composite. 9 is prime. 10 is a composite number. Some of its factors include 1, 2, 5, and 10. 11 is a prime number. 12 is composite. 13 is prime. 14 is composite. 15 is prime. 16 is composite. 17 is prime. 18 is composite. 19 is prime. 20 is composite. 21 is also composite. 22 is composite. 23 is prime. 24 is composite. 25 is composite. 26 is composite. So is 27. So is 28. 29 is prime. And 30 is composite. Okay, so now I want us to look at this color coding that we did, both circling our prime numbers. What patterns do you notice in the table above? For the most part, most of our prime numbers are odd numbers. The only even prime number that we have is 2. So I want you to write that down. 2 is the only even prime number. Okay, now I also want us to notice that multiples of numbers are not prime numbers. Okay, so what I mean by multiples of numbers is like 22. That's a multiple of 11. 24 is a multiple of 12. So multiples of numbers are also not prime. They would be composite numbers. So continuing on with our understanding, when we are prime factorizing a number, when we're going through the process of prime factorization, to determine the prime factorization of a number, you must break down a number into its factors, so into all of its numbers that when you multiply together get you your number that you're prime factorizing. Okay, so I want you to write down factors here. We're taking a big number, say 80, and breaking it down into all of its little factors, into the numbers that when multiplied together get you 80. So we're going to continue until all the factors are prime, breaking it down into only prime numbers. And prime factorization is written in exponent form. Okay, so that's why we focused on exponents yesterday, because you use exponents in order to write out the prime factorization of a number. So all that to say, let's go ahead and start practicing. Let's focus on this box right here. What is the prime factorization of 30? Okay, there's a couple different ways that you can write out your prime factorization. I like to use the prime tree. So if you have 30, I want you to ask yourself what two numbers when multiplied together get you 30. There's a few different options. You could do 3 and 10. You could also do 5 and 6. Okay, so what I'm going to do is 5 and 6 for the moment. I know that 5 is a prime number because when multiplied, only 1 and 5 get you 5. So 5 is prime. I'm going to go ahead and circle it because I'm done with that. I've already broken it down into a prime number. But 6 is a composite number. What two numbers when multiplied together get you 6? 2 and 3. Now I know you would probably want to write down 1 and 6 because you know that 1 and 6 make 6. However, 1 is not a prime number, so you cannot use that during prime factorization. 1 is off limits. So now that I've broken my 6 down into only prime numbers, 2 and 3, I'm done with my prime factorization. So my expanded form is going to be, starting with my smallest number, 2 times 3 times 5. In an exponential form, it is actually going to stay the same because I don't have any repeating numbers here. I only have 1, 2, 1, 3, and 1, 5. When multiplied together, get me 30. I'm going to go ahead and move on to the next problem. Question number 2. What is the prime factorization of 24? Again, this is a multiplication game, so let's go and write down 24. Start your tree. What two numbers when multiplied together get you 24? I know 2 and 12 make 24. 2 is a prime number, so I'm going to circle it because I'm done with that number. It's already a prime number. Now I'm going to focus on 12. Two numbers that when multiplied together make 12 are 2 and 6. 2 is a prime number, so I'm done with that one. Now I'm going to factor out 6. 2 times 3 makes 6. And those both are prime numbers. So my expanded form here is going to be 2 times 2 times 2 times 3. Because there are 1, 2, 3 2s and 1 3. So I have to write out all those numbers. Now if I write this in exponent form, my base number here is 2. And there are 3 of them, so that's 2 to the third power, 2 being multiplied by itself 3 times 3. And that's my prime factorization of 24. Now if I go back and I multiply all of these numbers together, I will definitely get 24. 2 times 2 is 4. 4 times 2 is 8, and 8 times 3 is 24.